So next we want to look at the electrical test that we can carry out on the circuit breaker, medium voltage air circuit breaker. So remember when we say medium voltage, we are talking of voltage that is above 1 kV, that is 1000 volts. Okay, between 1000 and about 60 kV. Okay, so the electrical test basically will carry out the resistance measurement on bolted connection as we used to do. Okay, so what we are trying to do is to ascertain that the connection is firm. Okay, but all of these bars, remember, it is when you are racking them in that they will be connected. So we may not have access to them, but we want to be sure that it is clean. Okay, sure that they are very clean. But if it is something that we can access the input cable and the output cable, we want to check the resistance at those connection points. Then insulation resistance, we can also perform it with the mega ohm meter. After doing the appropriate selection, that is on the selection switch, range selection on the selection switch, we test the insulation between phases. Okay, between line 1, line 2, line 1, line 3, line 2, line 3, line 1 neutral, line 2 neutral, line 3 neutral. Okay, and then each of these to ground. So we want to check their insulation and be sure that we have the appropriate insulation. So we want to check that it meets what is required in our facility. If there are no specification for our facility, we can check for what is recommended by the manufacturer of the particular circuit breaker that we are looking at, or else we can use this table. Okay, so since we are looking at medium voltage, so between here and here is the nominal voltage. So if we assume that we are looking at 11 kV, 11 kV is around here, so 2.5 kV test voltage, that's 2500, will be enough. Then we should be expecting a minimum of these resistance. Okay, 5000 mega ohms. So if it is less than 5000 mega ohms, then we need to check what is making it to be so low. And then if it is something we can improve, then we improve it either by drying out, okay, or seeing what we can do to improve the insulation. Then we also want to perform the contact pole resistance. If this is the circuit breaker now, we close the circuit breaker and test between the two contacts, these two bars, the input and the output bars. Okay, so that will help us to verify the contact resistance. So like here now, you have the contacts. Okay, this is an air circuit breaker, so we have to close it first and test it at the input and the output. So this stationary is connected to this particular bar, and then the movable contact is connected to this bar. So when it's closed, when we test it, what we are actually testing is the contact resistance on the pole. So we can use this to test the contact resistance by using the milliohms, section, or the low resistance section of this meter. This is a very versatile meter that we can use for all the tests that we need to do on the system. Okay, we can also carry out the insulation resistance test with it. This is the 1 kV range, especially on this medium voltage. So we can use the circuit breaker analyzer also to look at other parameters. Okay, the contact closing time, the trip time, okay, of the circuit breaker after receiving the signal to open or to close. All of those will look. We also look the travel time for each of the phases. If it is something that we cannot really assess the contact with the travel time of each of the phases, we'll be able to determine if all of them are closing at the same time or opening at the same time. So the control wiring, you also want to test their insulation to ground, but you want to be very careful and follow the instructions of the manufacturers. Okay. So with the breaker in the test position, because you are racking it, you rack it to the test position. So if it is in the test position, we can carry out the following tests. That you can open and close the breaker, okay, and then we use the control switch, okay, to open and close the breakers. Then we can also operate the protective relays, okay, to see that to see that the circuit breaker will respond to certain fault condition that is monitored or controlled by that protective relay. So also want to check that the mechanism is charging properly and that it is charging the closing and opening springs properly. Okay. We want to perform the minimum pickup voltage test on the trip mechanism using the circuit breaker analyzer. Okay, this is the circuit breaker analyzer. We want to perform all of those tests. We want to also perform the power factor test or dissipation factor test by the use of the power factor meters. Okay, so that is basically testing the insulation between the phases and ground for those high voltage equipment. So this one is more effective for us to determine the integrity of the insulation than the ordinary insulation resistance tests. Okay. So we also want to perform the dielectric withstand test, and if we do not have something recommended to us by the manufacturer or already in place in our facility, we can use this as a guide. Okay, so you see that we use a voltage that is higher than the operating voltage of the equipment, subject it to a very high voltage, and then see that the insulation will be able to withstand that particular voltage. So if it's able to withstand that higher voltage, of course it means that the insulation will perform properly when it is subjected to the nominal voltage. So we want to be very careful, because if the insulation is weak, it can cause the destruction of the insulation. So in most cases it could be destructive. So we want to follow our the instruction, already laid down instruction in our facility. So that is what we want to do during these dielectric withstand tests.